All right, well, Mike and I are going to kind of tag team up here. I just wanted to give an overview of NDOT's pavement preservation program. We define pavement preservation as anything an inch or less, so that's our thin treatments, our crack seals, to kind of differentiate it, because we have a huge preservation program, but it's a lot more than what this group would consider pavement preservation. So we've kind of been pretty steady over the last few years. From a contract standpoint in our capital program, we've done a little over $25 million this last year in preservation type projects. That worked out to 331 lane miles. Fiscal year 15, our predominant treatments, we did a lot of UBWCs or UBACs, whatever Kansas calls them. So it's the Nova chip. We're doing a lot more of the thin HMA. That's the 3/4 inch dense graded, used to be called sand mix, but now it's dense grade. And we've started doing a lot more CPR. We are building, or have built through our major moves program the last 10 years, we've built a lot of new concrete pavement. So we're getting more into concrete preservation mode. Clint's working a lot to try to get our in-house forces geared up to do a lot more concrete preservation. So from an in-house standpoint, we've done about 8,000 lane miles worth of work. That includes crack seals and chip seals, about $18 million worth. So we've done about 1,500 miles of chip seal the last fiscal year 15. We are a little bit down for calendar 15, and I'll explain that why. That's a good segue into what Mike's going to talk about. From a chip seal standpoint, we've got one district, one of our 6 districts, Southeast District, has made the switch over to CRS2P. We've been kind of making that push to get away from the anionics, so we finally got one district on board. We think 2 more are going to come along next year. We did do an experiment. We did a couple mile stretch with a lightweight aggregate that Kansas uses. We did that last fall after this meeting, and indications are it's performing very, very well. Friction standpoint, visual, after one winter it's looked really, really well. So we'll see how it performs after the second one. That job, like I said, we did a couple miles with the lightweight aggregate. The rest of the job was with our crushed gravel. So it's performing really well compared to our crushed gravel, and our crushed gravel is probably the best aggregate we have. Crack treatments, again, we are in the process of revising how we handle crack treatments from a material standpoint. We were one of the few states that still used emulsions, so we're going to be transitioning away from emulsions to all hot pour. We're going to revise the way we look at routing. We're only going to be routing transverse cracks on composite pavements. We've done some studies and research, or looked at some other studies that have been done to show that routing on other types of cracks or full depth asphalt doesn't have that much benefit for the labor involved. So the reason we're down a little bit on chip seals this year, our Southwest District started noticing that they were having a lot of problems with stripping. So they would chip seal a road, a year or 2 later, they were seeing some stripping issues, and they had a couple roads that were, Mike's got some pictures, really bad. So we put a moratorium in that district to try to figure out what was going on, what is causing this stripping, because we didn't want to go out and chip seal a road and then make it worse. So what Mike's going to talk about is kind of an innovative investigation for how we're looking at roads now before we chip seal them. So I guess with that, Mike.
Thank you, Todd. So picking up where Todd segued into my portion, what we in Indiana are identifying as preservation treatments are the thin HMA overlay, which is our 4.75 dense graded hot mix, ultra thin bonded wearing cores, the microsurface, and chip seal or seal coat. I'll focus some of the next few slides related to what we now know the problem to have been was moisture stripping. And we have a heavy causal relationship to the stripping to the preservation treatment. This picture is on a state road in southwest Indiana, what we refer to as our Vincennes district. And what you see in the picture on the right is wheel path stripping. And just one picture, but for the 13 miles, centerline miles of road was fairly continuous throughout. Probably the most severe example of moisture stripping that I had a chance to investigate. The picture on the left is a core that was taken, and the visual of that with the 5-inch tape there is you can visually see the amount of air voids that existed in the existing pavement. This core was taken post chip seal as part of our investigation, and it was not a matter of business practice for us to core the roads to ascertain what existed prior to doing some of our sealing treatments. So on the heels of investigating State Road 257, we decided that the district by this time had I believe 4 different state routes that had been chip sealed prior to any sort of initial investigation, and 4 jobs resulted in stripping occurring in the wheel paths. So as Todd mentioned, we had to place a moratorium to more or less cease maintenance operations, and we developed a forensic testing plan. And that plan hinged around the obtaining of cores. While cores cost money to obtain, it's a pretty cheap insurance policy compared to the backlash of a project that has deteriorated both from a public relations perspective as well as a financial perspective. The districts, when a road would go bad, typically did not have the money to address it, and they had to more or less rob money from something else that was planned in order to address the failure. So our attention focused on taking a set of cores, 6-inch diameter, once per mile for the entirety of the planned roadway segment. And knowing that the top 7 inches was of primary interest to us for the types of truck loadings, the 7 inches would be most susceptible to moisture stripping. So as in the little diagram that you see there, we more or less are looking at the 7 inches of HMA into 3 different sections. We're leaving the surface layer as its own investigative layer, and then the balance of the 7 inches would be split in half, resulting in an upper base layer and a lower base layer. And along with the forensics plan, we developed some test result limits and to help guide us in our decision making. And basically what we honed in to look at was the percent air voids that existed in each of the 3 layers, as well as the accompanying moisture, percent moisture. And what we were basically settled in, giving a good rating, would be if the in-place air voids were measured to be between 5 and 8%. If we had absorption of that, of all 3 of those cores to be less than 2%. And a procedure that's unique to Indiana, our research division helped to establish a percent water stripping test. We call it eye moisture. And basically it's taking a digital photograph of the core face and letting some specialized software help us in determining the amount of uncoated particles that exist in that layer. And the results from some of that in-house research established a threshold around 18%. If we were less than that value, there was no pre-existing stripping that was occurring in there. And then in addition to the good ratings, we have a cautionary and a poor, and you can see the resulting limits that we honed in on. So with the background of the forensics, the types of cores, a number of cores, and then some of the limits that we applied in our testing, the next few slides I'll focus on another road also in our Southwest District. This road was to have been planned to receive an ultra-thin bonded wearing course. The road's in relatively good condition from a serviceability standpoint. Good, decent IRI, and structurally it's very sound. So a preservation treatment seemed to be the candidate of choice. But on the heels of having done 5 or 6 of these investigations, are continuing to do these investigations, And ultimately, it was decided based on the results. I'm showing you here just the surface and not the upper or the lower base layer. The existing surface had a lot of red flags for us. The in-place air voids ended up being below 5%. There was some measurable rutting, although minor. There was some detected in it. And more to the point, the in-place absorptions for us were very much on the high side. And for those reasons, knowing also that the in-place surface contained a crushed gravel, and gravel's having a susceptibility issue to stripping, we decided that to waive off the use of the thin, ultra-thin bonded wearing cores, and instead opted a little more aggressive procedure to actually mill off this surface and replace in kind. So this has turned into a forensics tool that is guiding us in decisions. I'll try to keep just a few more minutes, a couple more slides. Some budding preservation initiatives that are occurring for us. While it may seem intuitive, this is something that we have not done much of. More and more, as part of our surface prep for any sort of overlay, we are milling. And milling for us can be as simple as a scarification, which is merely a roughening up and removing minimal amount of material, to a deeper sort of mill treatment. On the heels of some of our experiences with our thin treatments, and I'll focus for a second on the ultra-thin bonded wearing cores, those mixes, we had the belief that with the heavy polymer membrane, that could in and of itself serve as the crack filling treatment in addition to the bonding element for that thin mix. Well, some of the roads that got picked early on in our initiative were perhaps a little too far gone, had a little too much cracking. And what we feel ended up happening within a year of in-service conditions, the cracks came back, and came back rather aggressively. And we were worried that it had damaged the membrane and the whole system was susceptible to leaking and letting water continue back into the pavement. So within the last year, what we have started to do is, after completion of milling, is requiring sealing crews to come in, and for the cracks that are visible meaning a 1/4 inch or greater in width, we are filling them as part of the post-mill, but prior to the actual overlay. We've done a few jobs. The oldest one in service is just a little over a year, and honestly the results at this point in time look to be pretty good. And then lastly, due to some poor performing surface treatments, we have, as a necessity, have had to employ some milling in order to remove the distressed surface and restore safety to the road. Some of these issues arose for us rather late in the fall and did not allow us to actually, upon completion of milling, to construct the new overlay. And it gave us an opportunity to do a little study here, specifically related to friction. More and more for our thin treatments, and thin treatments for us meaning 1.5 inches or less, we require by our specifications that a fine mill head be the mill head of choice. And the fine mill head, for those of you that maybe don't know what that is twice as many teeth, cutting teeth, as what the typical coarse or triple wrap drums that we're mostly accustomed to. So twice as many teeth. As you can see from the table here, we have experience right now with 3 different jobs: State Road 257, State Road 58, and as well as Interstate 70, which was, for us, this section was in the west central portion of the state. What I show to the far right there, what's called FN at 40 mile per hour, that represents the friction number. So on State Road 257, before the incident that caused us to employ a milling technique, the in-place pavement had a friction number of 20, which is not a glorious number for us. After we had done the fine mill, we bumped our friction number up to 45, so very impressive. State Road 58, we had a chip seal that bled severely on us. It was an unsafe condition, so we employed the milling technique. So before we had a friction number of 35, after the mill it bumped up to 50. Interstate 70 was a very interesting study. We had some minor rutting in the wheel paths, and deep enough that it was causing some potential for hydroplaning. So we employed a fine mill just to remove the high bumps in the rut. And in many spots it gave us a textured surface in the wheel path. So the before treatment friction number was a 55. After the treatment it bumped up to 95. Now keep in mind that on the interstate our category of surface mix would require a blend of dolomite and slag materials. So that was a marketed increase up to a value of 95. After 6 months, we went back in and did another test, and we knew we had some degradation in our wheel path texture, but remarkably, for all of our gains, we'd only lost half of the gains after 6 months. So it's got us thinking that in a pinch, budget or otherwise, on certain roads, could we employ a fine mill as a surface treatment in and of itself. And we've done this, we're doing it under contract right now. Next week is the planned start date for removing 2 layers of chip seal on a relatively low volume road, and it's our intent to let that ride for about a year until we can next year reapply another round of chip seal. So to be determined, but this does look rather promising for us. I may have gone over a little bit, and I apologize, but any questions? Okay, thank you.